All right, we'll go ahead and get started. Hello, everyone. My name is Taylor Arthur, and I'm a marketing intern for the Developer Initiative here at Oracle. Thank you for joining us today at Oracle Cloud Coaching, Machine Learning, and Data Science. We're excited to be able to share with you how Oracle's data science platform allows you to build and deploy applications with comprehensive machine learning and AI capabilities in order to put your data to work quickly. If you have any questions during the webcast, please ask them in the Q&A area and we'll answer them live after the presentation. This webcast is being recorded and we'll make it available shortly after the webcast concludes. Here is the lab resource which will be utilized during today's session if you'd like to follow along. Today's webcast will be presented by Tom Fu, data scientist. So without further ado, I will turn it over to Tom.
Hey guys, can you guys hear me? Just checking my mic. Hi, yeah, my name is Tom. I'm a data scientist here at Oracle. I've been with Oracle for more than 2 years and currently serving as a data scientist at AACOE, Advanced Analytic Center of Excellency, where I help Oracle internal organization and teams to make use of the data and bring insights from the data, and also helping strategic customer to establish center of excellencies in their company and make sense of data and make use of their data assets. And today I will be presenting this Cloud Coaches session and introduce you to Oracle Data Science Platform, where we use it to bring value from data. So let's talk about data science first. How is data science conducted? First, you want to start with your planning phase. You want to see what kind of data you have. You want to see what is the business use case and how fast you want to deploy the solution, and what are different features or different kind of things you want to consider before you start your data science project. Next is the phase you want to build your model. So for building your model, probably not just one model. You want to have a various different model for you to use. And then after you get a list of different models, you want to evaluate them and see which one is the best according to whatever matrix you want to decide to use, whether it's accuracy or it's an R2 score or different kind of mechanism for you to score a model and see, to do some beauty context to see which one's better. After you picked out the one that suits you the most, you want to make use of the model by explaining it and see what this model can bring me and what kind of insight it can generate. So that will come to this explaining model steps. Lastly, when your model is ready for production, you want to deploy it so you can use new data set and new data points through this model and generates prediction for the future. So you not only generate prediction for your training data set or testing data set, you also want to generate prediction for your future. Like for example, I train a model that predicts what employee is gonna leave the company. You're not just gonna use it for now, you want to use it for later and see once there's a new employee come in, and we can see how whether this person will leave or not. And lastly, you want to, after you deploy your model, you want to monitor the model's performance and monitor how it drifts over time, whether the performance increase or decrease over time, and whether some changes need to make. And then if you decided to make changes, because as the name suggests, it's a data science life cycle. It's a cycle, so it's not one and done. So once you detect some changes in your model or some drift in the performance, you want to start from the beginning again, do another planning phase, and then start building out an upgrade of a model, and then the cycle starts again. So basically, this is a life cycle of data science. And then in today's demo session, I will show you how you can leverage Oracle Data Science Platform to go through this entire life cycle. And yeah, let's move on to the next step. We want to talk about a little bit about the benefits of having a platform. Traditionally, for data scientists, they work on their own. They might have a shared data set, but they each make changes to the data set. And then other data scientists probably will not know what other data scientists did to their data set and what kind of model the other people do. They work in a silos. So for a benefits of having a platform is one word, it's shareability. You can allow different data scientists on the same project to come together to share the data set, share their model, and share the snippet of different codes, and then eventually share the models for other people to use. So there's lots of benefits of having a platform. And as this slide suggests, the Oracle's data science platform are built for collaboration with various different users, whether you're an expert data scientist, you've been working on your own for a long time, or you're just a citizen data scientist, you just started on your own. This platform is basically for everyone. And this platform market is growing, and lots of people, from my experience with working with customer, I've been seeing lots of customer adopting to this platform and letting their data scientists to bring insights from the data set. So I'll pause a bit. This concludes my intro. I'll pause it for a bit to allow for any questions in the chat, and Taylor or anyone, if there's any question, you can shout it out and let me know. I can answer it for now. If no question, I will move on to my demo phase. Okay.
We have no questions at this time, yeah.
Okay. So let me start the demo. So for this cloud coaching session, we will be using Oracle Live Labs. Let me switch my screen. Can you guys see my screen? Is it everything okay? Oh, okay. So this is so there's a website I want to introduce. It's called Oracle Live Labs. So Oracle Live Labs. So in this website, you can not only use it for today's session, you can also do labs for other Oracle product or services as well. And today we're using the one for data science. If you want to follow along, you can do that, and then you can search it up. But the link provided in chat sends you directly over there, and then you can work this lab with a free trial tendency, which you can sign up at today's cloud coaching session, and then you can get extra credits for you to use. That's how you navigate it here. And today we'll be following along this workshop as a guide. I might skip around a little bit, but most of the content here will be brush on and touch on. And then after this session, if you want to try it on your own, you can, and just follow the link and then do it. Highly recommend getting hands-on for any people aspire to be a data scientist. But let's jump into the demo itself. So let me show you how you navigate to data science. So here, once you log into your data science, once you log into your Oracle Cloud Infrastructure console, there's a hamburger menu to the left, and then you can come down to analytics and AI, and then you can find data science here. So Oracle's data science is organized by projects. So project essentially is the highest level grouping of different data science resources. Project can be generates pretty easily, created pretty easily. You just create a project and then give it a name and descriptions. And then once you create a project, people with different logins, data scientists with different logins can come in here and collaborate. And then here I created one project for today's cloud coaching session. And then we can come in here. And next, we want to talk about a project. It comprises with 4 different kind of resources on the left, you can see. So notebook session essentially is where you will code up your model. You want to, and this is the kind of the playground for you to explore your data, cleansing and cleaning your data, and then deploying your, creating your model, and then saving it, and then using it to using the session to deploy it if you want to. It's basically a place for you to develop. And then jobs is a newly rolled out feature. It just came out of limited availability like a couple days ago. This is for you to schedule your task. For example, if you want your model to retrain every 10 hours or every 10 days, you can use this job feature to let your notebook or let your model to retrain every 10 hours. So you can use this feature to do that. And then model essentially is a model catalog where you can store all your models here. So once you finish developing your model and you're satisfied with it, you can save your model from notebook session here to the model catalog. And as you can see, I saved a few ones here, and then you can delete some of them. And then once your model is saved here, you can quickly deploy it by coming into the model that you want, and then say you want to create a model deployment, and then give it a name and description, and then the compute, which is the server that it will be running on, and then say what kind of shapes you want, and then how many of them you want. You can specify more than one, so it forms a cluster to provide you high availability. So in the case where one server goes down, other servers can pick up and help out the model deployment. So that's for you to use as well. And then for model deployment, and then you can come in here. This basically is when your model is in deployment, is running on the server that can generate prediction back whenever you hit it. So it generates the HTTP endpoints. So whenever you send any request to it, it will generate the model prediction back to you from whatever ways you hit it, whether hit it with a CLI, command line interface, or you hit it with Python SDK or Java. And here there are code snippet for you to copy and paste, and showing you how you can pretty easily just copy and paste into your application, and then your application will be able to hit the endpoint pretty easily. Any questions so far about how this is set up, or how these different resources are organized and grouped together? If not, I will move into the notebook section, where I will be talking about how you can use Oracle platform, data science platform to build out your models. So for you to go into notebook session is pretty easy. To create a notebook session is also pretty easy. You just hit create, and then give it a name, and also what kind of server you want it to run on. You can select whatever shapes you want. And one thing that I kind of want to mention is that for Oracle Data Science, you only pay for the compute cost, which Oracle has the lowest compute cost in the industry by far, as I know. And there's no additional add-in features, add-in pricings for having additional feature on your server. For example, in this case, our data science notebook. So by running notebooks on top of your server, you're not actually paying for anything extra. It's very cheap. You're only paying for the storage and the compute. And you also have the option to place your notebooks in the VCN, which stands for Virtual Cloud Network. As you desire, you can put it to different networks as you want. And then in the network, you can have network security configuration. If your company or your corporation desires, you can set up additional firewalls and all other network specifications that you want to protect it or to restrict it. But there are lots of things you can do once you place into a network, or you can place it into a private subnet, so your notebook can hit the internet, but the internet will not be able to hit your notebook for security practice. So yeah, that's how you spin up a notebook session. Because I already have one spin up, so I'm just gonna jump right in. Once you jump into the notebook, you will have this launcher. So I will go over this launcher a bit. So launcher, you will have different notebooks, Conda environments that you can spin up your notebook from. So Conda environment, for anyone who doesn't know, is a way for you to organize different environments. So for example, one, you can have TensorFlow, the other one, you can have PyTorch. So you can kind of separate different dependencies by different environment. And we have an Environment Explorer tab for you to see all different condas that you can be using. As you can see, you have TensorFlow, you can have PyTorch. It even has it for you to separate by filter by CPU or GPU. So I forgot to mention here, when you spin up your notebook session, you can actually say you want a GPU. So it has GPU support. And then once you spin up a GPU server, you can come in here and pick a GPU conda, so you can train your machine learning model faster. So you can just have different kind of conda environment here. And next one in this launcher is this notebook examples. So you can pick whatever environment that you want. Here I only have one environment installed. And then within this environment, there's different sample notebooks for you to kind of learn about how you can do different kind of things. So it really helps you and speed up your process. And today we're using this binary classification attrition notebook. I already spin it up. It's already here. So I'm not going to create a new one. So this is the notebook that I will kind of go through today. For the interest of time, we're not going to execute all those codes because it might take time to run and train model. I will go through this notebook to kind of go over what are some features that Oracle provides. We have a proprietary Python package called ADS. ADS stands for Oracle Accelerated Data Science. As you can see here, it does lots of things that the data scientists will normally take probably a longer time to do. It helps you to kind of speed up the data science lifecycle a lot more faster than normally would do. So let me just jump right into this notebook session. So you're setting up by importing different libraries. And then in this case, we want to do a binary classification of the data set. So this data set is an attrition data set. I loaded it locally in this notebook. So from this notebook, from this data set, we want to kind of predict what people will leave the company or what people will likely to stay. So you can load in the data set pretty easily with one line of code. And then lots of data scientists will agree on me on this. For you to explore your data set, it takes a very long time for you to do data exploration and then generate different plots to understand the data. But when you're using ADS, it really speeds up and simplifies this process. You can just run one line of code to say show in notebooks, and it tells you numbers of different columns and what types they are, and also generates summarized statistic of your data sets, like what are the means and variance and how many unique of them, how many missing. So it generates it pretty nicely. And it also generates a plots or a graph for every single column. As you can see, what are distributions of age and what is the distribution of the target variable, in our case, attrition, how many people are actually leaving, how many people are not leaving and staying, and then how many are travel for work. So all these graphs that I can continue scrolling are generated with basically just one line of code. So it really simplifies your data exploration process. And additional graph can be generated pretty easily as well. And you can see this shows your correlation of different features, and see there's a cloud of different correlations. That means lots of features are correlated with each other. Like years in industry probably correlated with your salaries or those kind of things. So everything is pretty easy to generate with the help of ADS library. Yeah, you can continue generating more graphs and to do data explorations. Next, after we finish analyzing our data, we want to make some changes to data set, whether that means some columns are unnecessary, so we want to drop them, or other columns has too many like missing values that we want to drop them. For data scientists, normally you would go through one by one and then to do cleaning. But with the help of ADS, you can just with one line of code and it auto transform, as this method suggests, auto transform the data sets for you and dropping all the unnecessary columns for you. And then you can add in additional parameters to say whether you want to fill in the missing value by different kind of methods or those kind of things. So there's lots of things you can do with this. And right now it does it automatically for you. But however, you can say, suggest recommendation where you can say, hey, I want this, but I don't want that. Hey, I want this, but I don't want that, to transform your data set a little bit more control over transforming your data set. Yeah, if you have any questions, please shoot out in the comments or the chat area, and then one of us will shout out the question and I can answer it on the go. And if not, I'm just gonna continue on demoing.
Hi, Tom. We actually do have a couple questions submitted in the Q&A area.
Yes. Can you?
So for our first one, someone asked, can a user or student use the data science service to run his model, to run his job or machine learning model and have the instance turned off as soon as the job is finished?
Yes. So it will not have the serverless capability that you're kind of referring to in your question. So it's not gonna run it and then shut it off by itself. However, you can easily turn it off after you're done manually. Like here in this notebook session, I can deactivate it after I'm done with it, or I can scale it up if I want to after I deactivate it and reactivate it. And then as for jobs, yes, you can create a job and then you can deactivate the jobs once you think it's done. But usually job kind of runs forever, because if some jobs are like you retrain your model for every 2 minutes or every 10 minutes. So you need the server to continuous running. Same thing goes for the model deployment, because your model is in production. So you don't want to shut off your model after it generates just one prediction. It is a production model, so it constantly getting data and constantly getting something back. So by design, it's running forever, but you have the option to turn it off anytime if you want to. Hopefully that answers your question. And next question.
Someone else asked, is the container option available for deployment?
So the backend, I believe, uses container, but I think the PM team has container deployment on the roadmap. Yes. So you can spin up containers for deployment directly, but I believe the product team actually uses the container as kind of the technology behind the scene, under the hood, for this this feature for this product. But I don't think user will have the options to use container directly in here. However, we have other features, other products at Oracle, such as Oracle Kubernetes cluster, where you can just provide your Docker image to it, and then it's a managed Kubernetes service for you to deploy your server. So if you want to deploy your data science Docker image or your Docker container directly, I would recommend using some other services rather than this one. But it is capable of doing it in Oracle, but just not specifically this product. Yeah. Any other questions?
Yes, just one or two more. For consuming large amounts of data like images, can notebook mount to storage?
Yes. So you can add until 10 terabyte of data to your notebook session, as you can see here. The minimum is 50 gigabytes, but at most you can go up to 10 terabytes. So whether you're storing video files for your deepfake video or other like images or computer vision tasks, you can have the option to go up to 10 terabyte. That's more than enough for everyone. And you can have the GPU options for you to train any computer vision task. So yeah, I hope that answers your questions.
Thank you. And lastly, for that one line of code, how does it determine which graphs or statistics to generate? Is it specified within that one line of code, or does it automatically determine that statistic or graph you need?
So it automatically generates the statistic for every single column. So however, not all of them will have a value generated, as you can see. Sometimes, for example, age is a numeric variable, so it generates the quantile for all or every single one of them. But for like attrition, which is a binary variable and it's a string variable, it doesn't have these things. To answer your question, it generates all the statistics for all of them, but not all of them can get populated because some of them are just not generatable. And then as for the graphs, it generates graph for every single one of them. And then sometimes if your data set is spread out, or in this case, the numbers are like not enough for you to generate like a chart or a graph. It's just gonna like show you some of them. And then if your data is spread out, I'm looking for an example here, but might be too many. If your data is spread out, instead of generating bar chart, it will generate some box plots for you. If your data is too spread out for you to kind of generate this kind of like bar chart. So it automatically does it for you to generate those like plots for you. If you don't want that, you can simply write code your own, but it's just gonna take a lot more time since as you can see, there are lots of features for you to kind of generate. Yeah.
All right, thank you, Tom.
Okay, so yeah, so I hopefully that answered all your questions about the data exploration. Now I will be jumping into the exciting part, which is the building and visualizing a model. So Oracle has Oracle AutoML. So AutoML is not a concept that's specific only to Oracle. AutoML has been a hot topic in data science nowadays. So what it means is that traditionally data scientists need to build their own model and then pick whether it's linear regression or it's a random forest, whether it's X gradient boost. They need to pick the model, and then once they pick the model, they need to train the model, and then if the model is not good, they need to tune the hyperparameter, and then back and forth, and lots of like trial and error in order to finally get a best model with one given data set. So AutoML comes in because it helps data scientists to do this kind of trial and error process. So it's automatic, so AutoML, as the name suggests. It automatically runs your data set on various algorithms and then try out different hyperparameters for you automatically. You can read a lot more into this in the notebooks, but that's the high level about what AutoML does. And in order for you to use it, it's very easy. You just generate AutoML instant and then providing the training training data set. And then you have the option to say what kind of models that you want and what are some features you for sure want to keep. And then what kind of scoring criteria or matrix that you want for AutoML to rank different algorithms or hyperparameters. And then because there's always a better one. So if you don't want your model or your AutoML to run forever, you can specify a time budget so that it limits your time. It doesn't take forever. Here is some output of AutoML. So this is the log of what it actually does behind the scene. So it tunes different things and then try different algorithms like hyperparameter tunings and adaptive sampling, feature selection. It does everything behind the scene. If you want to see the logs, you can, but I think it's just too much for me to kind of see what's going on. So I just hide it here. And then you can review the accuracy of your model by running all this code, and then you can see what kind of parameter you end up selecting. You can rebuild your model with those parameters if you want. But here is the best model that is spits out after you tried out different things. It tries out tuning, trials, adaptive sampling, model selection, and feature selection. So And then it ranks the model, the logistic regression is the best. As you can see, different kind of graphs showing what's done behind the scene. This is the graph showing there are more than 25 features, but we did some feature selection. We're only picking around 24 of them. And then the hyperparameter tuning along the iteration and numbers of iteration, how did it actually increase the score with different parameters. So there's a lot more behind the scene that you, and then if you want to see what's actually under the hood, you can print out different trials and examine what actually AutoML does. But for starters, AutoML really speeds up your process of creating a model. You just tell, hey, give me something, and then it just gonna generates it automatically for you. And then for ADS, Oracle Accelerated Data Science, you can actually import your model from third-party libraries. And in this case, we created a random forest classifier from sklearn, and then we can convert it into an ADS model by just using from estimator methods, and then it converts a third-party model into Oracle ADS model. And then once you convert your third-party model into ADS model, you can use the AD model to do evaluation. So we built, as you remember, we built a model using Oracle AutoML, and also we have a random forest model built using scikit-learn as here. And then we can compare two models using evaluator, as you can see here. AutoML classifier outperformed most of the categories in testing, but a random forest model is overfitting everything in the training data set. So you can do those evaluation pretty easily with just using the ADS methods called ADS evaluator, and then you can kind of compare which model is better in your case. And then you can continue using explainer for you. There are like two different kind of explanation that you can generate. So one is global explanation, which will show you kind of the feature importance of your data set of your model. So your model is seeing that over time is the big feature in explaining whether someone is going to leave the company or not. And then monthly income comes second. So on the overall, like global sale of your whole data set, your over time is the #1 predictor of whether someone is going to leave the company or not. So that is the global explainer capability. However, you can also do, so there's a lot more interpretation of different kind of graphs you can go into. I'm not going to explain every single one of them, but there will be documentation for you to read on what this graph mean and how you can interpret them. Yeah, so there's lots of capability to it. The next kind of explanation will be local explanation instead of global. So global is explain the whole data set or across the whole company, what makes sense, what is the feature that explaining people leaving. And then for local explanation is zooming in one specific individual or one specific record and see for this specific record or this individual, what is actually causing this person to leave or stay. Here is one example of we picked out from the model. So this is also some nice UI and graphs that the ADS generates. So the model, the true target variable is saying this person is not leaving, hence it's a false. And the model is predicted correctly, this person is false. So this person is not leaving. And then it shows you a probability of this case of being false or true. And then here it shows the features of this particular record, and no overtime, number of company worked, a number of company that this person worked, and years on the job, and what are the titles. This is the features of this particular record. And then what was cool about this thing is this explanation graph it generates. So for this particular person, because he's not working all the time, so the probability of this person leaving is decreasing. However, this person has worked in 9 different companies, which is greater than 7. So the probability of this person likely to leave again is higher. And the job satisfaction is lower than 1. So this person is, yeah, it's likely to leave. But however, some other things. So back and forth, this kind of graph shows you what different features are explaining this person is likely to leave or not. And then the result is the model is predicting it's not likely to leave. And then with different kind of like features, it's dragging it this way and dragging the other way. So it's kind of fun to kind of see any particular person and why this person is likely to leave. And as for business value, if you're an HR person, you say, oh, this person, job's environment satisfaction is low, so maybe I can enhance the environment satisfaction. So this person is not likely to leave. So you can tailor a solution for a particular customer, not customer, a particular employee, and then to kind of make them happier and stay in the company. And yeah, so that is about the model explanation, and then how you can kind of make sense of the data set and make sense of the model and use the model to generate business outcome and business insight. And once you're done with building your model and evaluating it and then explaining it, you can save your model into the model catalog. So, and then here, if I execute this code, it's gonna generate some model artifacts and then save your model. Come back to the project and then save your model into the model catalog here. As you can see, this is the time right now. So the model got saved here. And once your model got saved in the model catalog, as I demonstrated earlier, you can create a model deployment and then deploy it to a server. And then it keeps running over there. And then you can feed in more data to the model deploy and then get results back pretty easily. So yeah, this concludes my demos for Oracle Data Science. I'm ready to taking any questions.
Thanks, Tom, for the wonderful presentation. We're now going to address any additional questions that have been submitted. So our question for you is, before we run the model, does AutoML perform feature engineering or extraction?
Yes, so it does the, well, let me kind of step back a little bit. It does all feature selection. It does not do feature engineering. So for you, if you want to, for example, you want to combine some features and make it a new feature, you have to do it on your own before you feed into the AutoML. AutoML does feature selection, but it doesn't engineer or generate new features for you. So if you want to do PCA, or if you want to generate some, for example, a salary column is not generated, but you only have monthly rate of this person, and then you need to times 12 to generate an annual salary. So you have to do it on your own. But yeah, so that hopefully that answers your question. Yeah, it does feature selection. They can see whether some feature can be dropped or not, or some feature are not really explaining a lot, and they likely not be selected. But it's not going to generate new features for you.
And then another question for you, Tom. Do we have an option to use RStudio similar to Python Notebook here?
So to answer that question, RStudio is not supported in Oracle Data Science platform. It's mostly Python based. However, because RStudio can be installed using Anaconda, and Anaconda is included in the data science platform. So you can install R on it and then work with R. But that is not what PM team is recommending. So data science, Oracle Data Science is mostly a Python environment for Python data scientists. But you can install R on it. It's not going to come with all this nice ADS feature. And yeah, it's not gonna, because OCI, Oracle Data Science, is mostly a Python shop rather than an R shop.
Okay. Can you install third-party or open source packages?
Yes, you can easily install any third-party packages via just pip install. So if you go into your launcher and then you click onto your terminal, and then because you have terminal option assets, and then you can easily just pip install any third party, or you can even install GitHub, or you can any kind of libraries that you want to install. You can definitely.
Can you go into what the pricing is for a data science platform?
So the pricing is, so you only pay for the infrastructure, you're only paying for the compute and for the storage. You're not going to pay for any premiums for having data science. So, and then the pricing will be the same for you spinning up, like, for example, if you spin up a notebook session that is like a VM 2.2, and then it's just going to charge you VM 2.2 and then charge you $50 of, not 50, oh shoot, 50 gig, the price of 50 gigabytes of block storage. And a sales rep, or you can go to the cost estimator on Oracle website to actually calculate the actual price. But what I can tell you is that it's not going to charge you any extra like on top of the infrastructure costs.
Mm-hmm. Are there capability overlap with Databricks?
Databricks, I believe there's some conda for you. So if you come in here, there should be some conda for you to link to Databrick. Or if not, then you can install some third-party Python packages for you to link to Databrick. I believe in Databrick as a service will be rolled out on Oracle Cloud Infrastructure later on as a feature engineering kind of add-on feature in the next release of data science. As for now, it doesn't have any feature engineering or Databrick capability yet, but you can certainly do it DIY yourself. But later on, it's gonna roll out, and then everyone can everyone doesn't need to DIY it, and then it comes with it. But that will be on the roadmap. The PM team can speak more to it, but that's what I know.
Can it connect to data stored in the cloud or other places?
Yes. So let me show you a documentation. Oracle ADS documentation. So let me show you a documentation. So we actually have a documentation of this ADS, Accelerated Data Science SDK. And then it has lots of things you can go into. So to answer your question about loading data from other storage, as you can see, if I click loading data, it actually can take in data from various data sources, like data sources from Oracle Object Storage, even from Amazon S3, Microsoft Azure, or Google Cloud Services. You can even take in data from like Database or Hadoop or any other kind of places that you store your data. It takes in various data formats as well, not only CSV, but also Parquet or Excel or other things. So there's lots of flexibility in it in terms of like loading data. Yeah, and then this documentation goes through how you can connect to different data sources. You can read all about it here.
Alrighty, and does it have GPU support?
Yes, as I showed in the demo, it might be too quick, but as you can see here, if I want to create a notebook session, and then you can pick whatever shapes you want. It has NVIDIA GPU support as well. So you can see it here. When you spin up your notebook session, you can spin up a GPU server. Or if you want to spin up a CPU first and then switch to a GPU later, and then train your model and switch it back to a CPU, you can also do that. And it also has GPU condas for you to leverage the GPU infrastructure. So yeah, it definitely has GPU support.
All right, if there are no more questions, I'd like to provide some brief information on what cloud coaching is and how to request your own cloud coach. If you're experiencing a roadblock that isn't serious enough to warrant a service request, or maybe you just purchased OCI and are looking for an additional onboarding session, cloud coaching clinics pair you one-on-one with a cloud engineer to assist you on your cloud journey. We offer workshops and demos for deeper dives on our particular service, provide sample code, and provision and configuration services. Please visit the link on this slide to sign up, and I'll also provide it in the chat now. And then here's that link again for you on the slide. If you enjoyed today's session, you can also sign up for next month's cloud coaching session on Identity Cloud Service. Here are also links to other developer events, the demonstration resource from today's session, your trial again, and we'd love to hear any feedback that you may have for us. Please feel free to send any questions about today's session, suggestion about future topics you'd like for us to cover, or how to request a cloud coach to our email at cloudcoach_us_grp@oracle.com. I'd like to thank Tom again for this phenomenal presentation, and thank you for spending your time with us today. So I'll go ahead and end the session. We hope that you have a wonderful day, and we hope to see you again next time.
Thank you.